Today, we're going to be talking about converting fractions to decimals and to percentages, so let's get started. So, the key concepts here, if the denominator of a fraction is a factor of 10, 100, 1,000, and so on, then all we need to do there is multiply the numerator and denominator by the appropriate factor pair. But if the denominator is not a factor of one of those numbers, which not everything is, right, then we can use long division in order to figure it out. So I'll be going through two examples today, one of which we can use the first method and one of which we'll need to use the long division method. So let's start with this first one. It says to convert 3 over 20 to a decimal and to a percentage. So first thing I'm going to do is ask myself, well, for 3 out of 20, is 20 a number that, that has a multiple that is 100, 1,000, 10,000, and so on? And what's the smallest one that it could be? And my answer is yes. 20 times 5 is 100. And so therefore, all I need to do is multiply the numerator and the denominator by 5 to get that 3 over 20 is the same as 15 over 100. Now, a percentage is just a fraction out of 100, so to switch this to a percentage, I'm going to just write 15%. And as for decimals, recall that for decimals, we have the different place values. So this place here, right after the decimal, is called the tenths place. And then the second one is the hundredths place. And then a thousandths place, and so on. And so in this case, because it's out of 100, that means my final digit, which is 5, needs to end up here, and then all the other numbers accordingly. And so therefore 0.15 is the decimal version of 3 over 20. The reason we're kind of doing decimal and percentage together is they're pretty similar. Notice that the digits in decimal and percent are the same, it's just the placement that's different because percent already accounts for dividing by 100, whereas a decimal number does not. We have to make sure that the place values are correct for the decimal. All right, let's do a second example. Convert 3 over 7 to a decimal and to a percent. Now, because this is a fraction, that means that the decimal type that we're going to end up with is going to either be a repeating decimal or a terminating decimal. It can't be a decimal that never repeats and never terminates because otherwise we would not be able to write it as an exact fraction, only as an approximate fraction. And percent is the same as before, it's just the value out of 100. Now in this case with 3 over 7, we actually can't multiply 7 by something to get 10 or 100 or 1,000 or 10,000. We could multiply it by something to get very close to one of those things, but not exactly. And so in this case, we're going to use the long division method. So in this case, we are going to have 7 out here and 3 in here. Now I'm going to put 3.0000 and just see what we end up getting. We can always add more zeros to this if we need, because recall that 3 is the same as 3.0, which is the same as 3.00, and so on. Adding zeros to the right of a number that is already a decimal number, adding more zeros on doesn't change anything. Just as if we are doing a non-decimal number, adding numbers to the left doesn't do anything, right? 0, 3 is the same as just 3. So how many times does 7 go into 3? Well, it doesn't, right? 7 is larger than 3, so none. How many times does 7 go into 30? Well, 4 times, because 7 times 4 is 28, and that's the closest we can get to 30 without actually going past 30. 30 minus 28 is 2, and then I'm going to bring down the 0. How many times does 7 go into 20? Well, 7 times 3 is 21, so that would go slightly over, so it's going to be 2. 7 times 2 is 14. 20 minus 14 is 6, and I'm going to bring down the the 0 rather, not the 7. How many times does 7 go into 60? Well, 7 times 9 is 63, so that's a little bit too high, but 7 times 8 is 56, and that will work. And then I'm going to subtract, and we're going to get 4, and then I'll bring down the next 0. And actually, I'm going to move this up here because we're running out of room, and I do want to show this in full, not just partially. There we go. That's going to work a little bit better for us, hopefully. Okay, so how many times does 7 go into 40? Well, let's see. 7 times 5 is 35, and that is indeed the closest we can get without passing. So I'm going to write 5 up here, and then we have 35. And then if I subtract, I'm going to get 5, and I'll just add a couple more zeros here. We'll bring down the 0 again. And we're just going to keep doing this until we end up having the decimal end. So either if we get a remainder of 0, that means we're done, we can stop. Or if we end up getting one of these same numbers again, like if we get a 4 again, then we know that, oh, that means the whole pattern repeats again because we're just repeating more zeros again. And so if we got a 4 next, for example, not saying we will, but if we did, we would know that we would just keep repeating the same values again and again. Okay, so in this case though, 7 goes into 50 how many times? Well, 7 times 7 is 49, which is very, very close, so I'm going to go with that. 50 minus 49 is 1, and I'll bring down the 0 again. How many times does 7 go into 10? Well, 1 time. 7 times 1 is 7, and then I'm going to subtract, and we get 3. And that's good news. Finally, we're about to get that repeat because we bring down the 0, and we have 30 once again, which is exactly what we had for our first one. So how many times does 7 go into 30? Well, 4 times, and then we're going to get the same thing again. We're going to get 28 again. Then if we continued, we would get 2 again, and then therefore bring down the 0 again, get 20, put a 2 there, and so on. And so as soon as we get this as a repeating digit, that tells us that this whole pattern is starting again. So the answer is that this is 0.428571, and all of that repeats. So it's 428571, 428571, 428571, just forever. It's going to repeat. And that's why I'm putting this bar on top of it to show it repeats. If it was a terminating decimal, so if it was at a case where we got a remainder of 0 at a certain point, then in that case we would not put that line there because that would not be repeating. That would just be a decimal that ends at some point. Now that said, just a reminder that every decimal will always either terminate or repeat when that decimal comes from a fraction. There are decimals that exist that do not terminate and repeat like pi, for example, or like e. However, those values are irrational numbers, meaning they cannot be written as fractions, and so therefore it wouldn't work that way. So that's our decimal answer. Now, what about our percentage answer? Well, recall that a percentage is just the value out of 100. So to go from a decimal to a percent, we just move the decimal point 2 places, and then we just move the decimal point over 2 places to the right and then write a percentage sign. So it would be 42.857, and then all the same stuff repeating again, percent. And actually, let's make sure you guys can see that. There we go. And then 428571, all that stuff repeating, percent. Or honestly, we could probably even just round it off and say it's approximately 42.857%, and that would be acceptable as well if we wanted to just say this is our answer approximately, because at some point we're going to have to cut it off or write the repeating symbol. But as always, feel free to ask any questions you might have in the comment section, and we'll see you for the next one.